This is R.D. Sharma solution, class 10 maths, chapter 13, exercise 13.2 of probability. Here the probability is geometrical probability. So geometrical probability, the idea is we take the complete area, that is complete area, and the favorable area or the area of importance, that is you can say favorable area, and we divide them and then we get the geometrical probability. For example, here in this problem we have to drop something, let it be tie or something else, in this rectangular region. This is rectangular region. What is the probability that it will land inside the circle with diameter 1 meter? So here we have a circle with diameter 1 meter. So what is the probability that the content or this thing which falls here, but the region is total, it may fall anywhere, it can fall here, 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 but we have to find the probability of this region, the circular region. So as I said, first of all we have to measure the whole region. So area, you can say area, complete area or complete area region. So this is 3 and this is 2. What is the area of a rectangle? 3 into 2, 6. Now this is a circle, so it will be pi into 1 meter is diameter. So you always know that diameter, radius equal to diameter by 2. So it is 1 by 2, that is 0.5. So pi r square is the area of the circle, pi into 0.5 whole square. So this is going to come 0.5 whole square, that which is equal to 0.25. 0.25 by 6 is going to be pi by 24. Again in this figure there is a fair spinner which is placed at the center O of the circle. Now diameter AOB, this is diameter of the circle AOB, and radius OC. Divide the circle into 3 regions. One is X, one is Y, and one is Z. 3 regions are there. So let me show you the region. This is one region. This is one region, second region, and third region. What is the probability that the spinner will land in region X, that is this region? So first we have to find out the complete area. Complete area will be pi r square, pi into, let us assume that the radius is r. So pi r square. So what will be the area of this region, which is our importance of favorable region? It will be, first of all we have to find out this area. So area will be, this is a sector of a circle. So area of a sector of a circle is theta by 360 into pi r square. So if this is 45 degree, this whole is 180 degree. What will be this angle? 180 minus 45, that is 135. This angle will be 135. Theta will be 135. 135 by 360 into pi r square. So this will be 3 by 8. So just put 3 by 8 pi r square here. This gets cancelled. So this gets cancelled. So it will be 3 by 8. This is going to be 3 by 8. Again in this figure, this consists of 3 concentric circles of radius 3, 7 and 9. So we have a circle of 3, then 7, then 9. A dart is thrown. Dart means anything which has to be thrown, lands on the target. What is the probability that the dart will land on the shaded region? And what is the shaded region? This one is the shaded region. This is the shaded region. So in order to find out the area of the shaded region, first we have to find out the area of this 7, circle with 7. Then we have to find out the area with 3. And then we remove this area. Means the smaller circle area has to be removed from the larger circle. Then we get the area of this shaded region, this region. So this will be pi, the outer is 7 square, pi r square, minus this pi into 3 square. So when we subtract this, this is 49 pi, this will be 9 pi, and this is going to be 40 pi. This is our favorable region. And what is the whole area? This is the complete area, which is the highest radius is 9. So pi into 9 square, it is 81. This is going to be 40 by 81. This is the answer. So favorable region divided by the complete region is the geometric probability. In this figure, we have A, B, C, D. A, B, C, D. These are the centers of 4 circles that each has the radius of 1 unit. So the radius is 1 unit. If a point is selected at random from the interior of a square ABCD, what is the probability that the point will be chosen from the shaded region? So if the point has to be taken from square only. So this is our complete region. Means square is our complete region. So what is the area of the complete region? See, this is 1 and this will be 1. This will be 1 and this will be 1. So the sides are 2. This is a square and side is 2. So the area of square is side square, which is 2 square, which is going to be 4. So let us put 4 here. Now we are interested in finding this shaded region because this is our area of importance or favorable region. So how can we do? If we subtract this 1, 2, 3, 4 quadrants or 4 sectors from this square, we'll get this region. So what is the area of square? We already found this 4 minus. We have to subtract these 4 quadrants. What is the area of one quadrant? It will be theta by 360 into pi r square. But this is 90 degree. It will be 90 by 360 into pi r square, which is going to be pi r square 1 by 4. But these are 4 region, 1, 2, 3, 4. So we have to multiply 4 with 1 by 4 pi r square. So it will be pi r square. Okay, it will be pi r square. So let us multiply. This r is what? Radius is 1. So pi into r square, pi into r square, that is pi. R square is 1. So 4 minus, what is the region of what is the area of these 4 quadrants? It will be 4 minus pi only. And this is the favorable region. And what is the complete area? Which is 4. So 4 minus pi by 4, we can write it as 1 minus pi by 4. This is the measure of specific part of the region, measure of the whole region. This is the geometric probability. In this figure, JKLM is a square with side 6 units. So now these are square with side 6 units. Point A and B, these are the midpoints of side KL and LM. So this is 3, this is 3, and this is 3 and this is 3. If a point is selected at random from the interior of the square, what is the probability that the point will be chosen from interior of triangle JAB? So essentially we have to take this complete region, which is 6 into 6, because this is a square. 6 into 6 will be 36, or side square will be the area, and we have to find out this region. How do we get this region? This region can be found by subtracting the triangle 1, triangle 2, triangle 3 from this square. So let us find out the area of this first one, which is half into base. Base is what? You can take this base or this base. Half into base into altitude. So 3 into 6. Half into base into altitude. How about this one? This third one? Half into base into altitude. So again, half into base into altitude. How about this triangle? 3 and 3. Half into 3 into 3. Base into altitude. So this will be half 3 into 6, 3 into 6. So this will be 3 into 6 only. Plus 3 into 3 by 2, 9 by 2. This is 18 plus 9 by 2. So this will be 36 plus 9 by 2. This is 45 by 2. And now this has to be subtracted from this one, which is the actual area of this region, you can say. So what is the area? We just found out that the area of the square is 36. So we have to subtract this one, and this one from this whole area so that we get the internal region. So it will be 45 by 2. It should be 72 minus 45 by 2. This is 27 by 2. So 27 by 2 is the area of this region, which is the favorable region. 27 by 2. and this is by 6 6 is 36. So what do you get? 27 by 2 by 36, you get 3 by 8. Okay, 9 3s are 27, 9 4s are 36, so 3 by 8. This is the probability of choosing a point from the interior triangle AJB. Now we have a square dartboard which is shown. The length of the side of the larger is 1.5 times the length of the side of the smaller square. So if you assume that the length of the smaller one is A, this will be 1.5A. If the dart is thrown and lands on the larger square, what is the probability that it will land in the interior of the smaller square? So this is our favorable region. So this is a square, so A into A is the favorable region. Now how about the complete region, which is 1.5A into 1.5A, 1.5A square. That is 1.5 A square total. So that will be A square by 1.5 square is what? 2.25 and A square. So 1 by 1.25, 1 by 2.25, 2.25 will give you this 225, 100 by 225. This is going to give you 4 by 9. 25 4s are 25 9s. 4 by 9 is the geometrical probability. Always remember, for the geometrical probability, it should be measure of specific region part which we are interested and divided by the measure of whole region. So this is all about this topic. Thank you so much. Take care of yourself.